Hello everyone, myself Rucha Anil Shinde. I am Assistant Professor at Jnanashri Institute of Engineering and Technology, Sadara. This presentation is created during week 2 of International FDP on Environment and Sustainability, which is very specific to environmental standards. Subject for this presentation is Design and Analysis of Algorithms. So these are the week 1 video details. The contents were green computing, energy efficient programming languages, and using efficient algorithms and data structures, and energy efficient libraries and drivers. So here I have provided my YouTube link. Number of likes were 4 and number of views are 18. So these are some ISO standards based on the environment. Now, here I am going to review a research article entitled Software Development Lifecycle for Energy Efficiency, Techniques and Tools. So the motivation is, in the modern IT systems, the increasing demand for computational power is tightly coupled with ever higher energy consumption. Traditionally, energy efficiency research has focused on reducing energy consumption at the hardware level. Nevertheless, the software itself provides numerous opportunities for improving energy efficiency. Hence, the goal of this article is, given that energy efficiency for IT systems is a rising concern, to investigate existing work in the area of energy-aware software development and to identify open research challenges. The use of parallel and approximate programming, source code analyzers, efficient data structures, coding practices, and specific programming languages can significantly increase energy efficiency. Moreover, the utilization of energy monitoring tools and the benchmarks can provide insights for the software practitioners and also raise energy awareness during the development phase. ICT-related products and services contribute to high energy consumption. The energy consumption of IT sector is rising faster than initially predicted and is expected to reach 15% of the world's total energy consumption by 2020. Besides, recent studies presented by climate scientists in the Smarter 2030 report that greenhouse gases due to IT, currently estimated at around 2.3% of the global greenhouse gases, and are growing much faster than initially predicted. A proposed method to counter ICT's growing energy hunger is through green IT, which is the practice of designing, implementing, using and disposing of IT-related products in an eco-friendly way. Existing research works in the area have tried to address some of the challenges for reducing energy consumption in the software development by defining appropriate matrices, employing energy measuring tools, and proposing best practices. So, here is the complete view of existing tools and the techniques for energy-aware software development. From that, the first is the requirement. The authors listed the following relevant instructions that developers can take into account. From that, some set of instructions I'm going to elaborate. First one is bulk operations to keep I/O calls minimum. Then hardware coordination, such as minimizing memory access. Concurrent programming, such as selecting appropriate thread construct. Efficient data structures, selecting less energy greedy data structures. Loop transformations, such as loop fusion to reduce the control operations. Data compression to reduce file sizes before the transmitting. Then offloading methods by calculating heavy operations remotely, that is on the cloud. And the last one is approximate programming to reduce unnecessary precision of computation. Now, the next is design. It has been observed that the negative impact of some design patterns in embedded and smartphone devices regarding energy consumption, and also identified that decorator and abstract factory as the most energy inefficient design patterns. So the structural changes in the design patterns can lead to significant energy optimization. Initially, the authors perform an experimental study where they manually applied around 21 different design patterns on 11 applications which were written in both C++ and Java. Their experiment revealed the observer and decorator as the most energy greedy design pattern. The authors transform those existing source code by reducing the number of created objects and function calls and accomplish important energy savings, especially after optimizing the observer and decorator design patterns. The authors reduce the application's energy consumption by almost 10% on average. Next is implementation. For implementation perspective, we can thought of parallel programming, where parallel programming is the process of breaking a large problem into smaller ones to solve them simultaneously. Then we can think of programming languages which will offer a set of instructions that allow users to utilize system resources to solve a problem. Languages differ in features and the way they allocate computing resources. So here is the table which shows the programming languages and their impacts on the energy performance. So almost they have compared C, C++, Java, Python, and some are assembly to see. Then next is what data structures. So data structure is a way to organize, manage and store data for further process or analysis, which summarizes work on the data structure collection, interface and library, energy consumption and tested application for the relevant source. So this is the table which shows data structures and their energy performance impact. So it has listed the data structures, widely used data structures like list, map, set, queue and the hashback. So now the next one is the verification phase. Now this belongs a range of tools to measure and test software's energy and power consumption. After the development of an application, benchmarks are tools consisting of two main components. One is the profiling tool responsible for obtaining instructions used from a specific execution, and the second one is the performance benchmark that generates workload for a system. The above components combine perform energy consumption measurements. To derive the energy consumption of a computer system, two approaches currently exist. One is the indirect energy measurement through estimation models or performance counter, and the second one is the direct measurements through hardware energy analyzers and the sensors. Then we are having the maintenance phase. Maintenance is the process of enhancing or fixing errors in a software after the deployment. For the maintenance phase, authors consider empirical evaluation of refactoring techniques and patterns for energy performance optimization that software practitioners may employ to reduce the application energy consumption. So this is what the reference from where this presentation is created. So we can conclude like overall analysis reveals that the techniques and tools to provide energy efficiency which exist for each phase of the software development lifecycle. However, for software practitioners to adopt and use existing tools and techniques, interoperability, usability and adequate support are the crucial factors. Thank you.